Okay, good morning. Welcome to Behind the Lab Codes. My name is Rahel Munima Akem, and then I'm much more privileged and honored to welcome you to this platform. Okay, so give us a brief introduction about yourself, and then we go ahead with today's task.
Okay, thank you very much. I'm also honored to be here. I'm in the person of Okore James, a graduate of engineering physics at the University of Cape Coast. So basically, that's all for me.
Interested. So, if I'm to ask, give us a general overview of engineering physics and why you chose the program as an individual.
Okay, as an individual, I had interest in many engineering fields. When I saw engineering physics, I was motivated because of how open and versatile it was. Per my research, I knew that when you take the engineering physics, you'll be exposed to other fields of engineering, which I also have interest in. So many other fields. So engineering physics is basically the application of the physics principle to solve engineering problems.
Interesting.
Yes.
So, if I'm to understand you, it's not only about studying the theories, but then it's about how best you can interpret the theories in practical.
Exactly.
Interesting. So, what are the challenges you faced as an individual?
Okay, personally, the challenges I faced was I had a physics background, but I felt like it was not deeply rooted because I think in my Form 1, in the senior high school, I really didn't get into the physics. But along the line, before I left, I wrote my East African examination certificate, got my certificate. I really understood the physics. So I think the beginning was rough. But I also think of the general challenge which we all face is a bit of stress. But, as humans, we want everything to be okay with us, but the stress is there because of the courses we take. Especially now, second year, you add courses and courses that you're given 2 math courses, you do statistics. But all this aside that have a great impact in the
Interesting. So, if I'm to understand you, upon all the challenges you faced, here we are enjoying, here we are smiling. You were able to handle the stress. So, as far as you're able to handle the stress and then come out successful, what are you telling those behind you? I mean, the undergraduates taking this program. What are you telling them to motivate them? Because some of them will surely watch this interview on this platform. So, what are you telling them? And how are you trying to encourage them to go about things?
Yes, I always tell them to look at the future. Because the future now is science, engineering, and technology. The STEM, that is why they are pushing for the STEM, right? For the younger ones. So I always tell them to look at the future and look at the passion. So what drives you? A lot of them will tell you they have wanted to do other engineering courses. And I tell them that yes, engineering physics expose you to all other engineering fields. If we look at the course contents of the engineering physics over here, and you look at some other engineering courses out there, you will see that they have related courses. Just that ours, because we are applying physics principles to solve engineering problems, they give us more of the physics courses, and which I see to be very, very beneficial because when you understand them, you can be able to see, okay, I can apply it in this field of engineering. I can apply this principle in this field of engineering. So I always try to tell them that there is no need to give up. You never made a mistake. The courses will expose you to the coding, the programming, the embedded system, and the whole lot.
Okay, so upon all the stress, we shouldn't give up. We should just focus on how we will get exposed to other fields in engineering. And then also, if I'm to ask you, what are you trying to tell those behind? I mean the SHS level, how they should take this program and how they should face their fundamental physics. How are you telling them to go about things? What you said earlier is for the university level. So for the SHS level, what are you telling them? How are you trying to push this program there since it is new to the system?
Okay, what I will try to tell them is physics is not difficult. Physics is just applying. Physics is our everyday life. So they should take the theory and see how it can be applied because every physics principle that is out there is what we are living on now. I would not like to go into mentioning principles and a whole lot. So law of flotation, look at how the boats, ship floats on the sea and a whole lot. They are all physics. our everyday life is physics. You see, when we also come to physics, material science, semiconductor, we are using them every day. So they should just look at the things around us and study the physics with the mindset of applying it, with the mindset of understanding its application, not just taking the chew and pour. Because I believe physics, you can't chew and pour, but people do it.
So this is what we are taking home. Physics is life, and physics is every day. So he was talking about how we apply heat and how flotation occurs. In fact, it's true. I can relate. But then the last question for you, Mr. James, what I'm trying to ask is, how has this program, engineering physics, have a positive impact on the university community as a whole?
Yes, it has had a great positive impact on the university community. So, currently, we have started a traffic light project, which senior lecturers of our department, they took it upon themselves to take up the project. So with the basic microcontroller they are teaching us, the embedded systems using the Arduino programming, yes. So they brought some students together and they started the project. So we have our first traffic light mounted, and we still have some we are working on in the lab. So a whole set, we are working on a lot of traffic lights on campus.
Interesting. So can you tell us something little about the embedded system?
So the embedded system is basically using a microcontroller, yes, to make components work. So we are using microcontrollers to work on devices.
Okay, so if I'm to understand, the microcontroller is not visible.
It's visible.
So how does
It's
it
visible.
work?
So we write languages, programs to embed it, deploy it on the controller for it to work.
Okay, so that's the coding aspect of engineering physics. We turn our theories into computer language, and then for machines and equipment to understand, since they can't speak local languages as we do speak. So we try to turn our theories into computer languages, and then they would rather translate and then proceed. That's everyday physics, everyday life. Okay, thank you so much for your time, and I'm much more honored once I